it.
Yep.
And 1, 2, and 3. Hi, everyone. We are the Inquiring, Exclusion, and Non-Active Listening team, and this is our final presentation. So, this is our table of content. We have the background, the analysis, and the recommendation. So, in order to first address the problem, we want to understand the context behind it. And the main goal is to go over the active listening tactics and its impact on objective sales. Enhancing sales, behavior quantification, two-way process, and listening strategies are all part of this contribution. And then here we have the objectives. So we have objective 1, prompt your identity as a college freshman that can understand and help you identify the active listening tactics. Objective 2 is to create a GPT-4 prompt draft to identify the tactic and provide the thought process to justify the prompt engineering process. And then lastly, objective 3, use GPT-4 to co-create a hypothesis on the focal tactics impact on sale outcomes. Moving on, we have steps 1 through 5. So essentially for step 1, we're setting up the chat. So we told GPT, I'm going to upload the file. Please review and summarize the content so that I know you understand what it's about. Then step 2, we set a persona and define the tactics. So we'll have, I want the examples to be explicit. First, we wanted to identify the 10 examples of active listening tactics, and then we'd have it to be explicit, remove any examples where anchoring is implied or the example is weak. For step 3, what reasoning are you using to determine the anchoring tactic being used? And then can you provide the best 10 examples of anchoring based on what we've defined so far? For step 4, methods of excluding similar but different tactics. We essentially had the salesperson, if the salesperson repeats, rephrases, or summarizes what the customer has said, then it does imply that they were listening to the customer. So the question we'd ask is, how would you define non-active listening anchoring? And then step 5, we formulate the hypotheses with ChatGPT, and essentially we'll have it as a college freshman where your task is to analyze customer service interactions to identify specific tactics used by agents. And after that, we'd have GPT go ahead and justify and elaborate its methods for the use of different tactics.
The goal of assignment 3 was to revise our prompt to improve the program performance. The first step we took was running step 1 code to use GPT-4 API to tag the calls for our tactic inquiring, and then run step 2 to use dictionary method to exclude non-active listening tactics and calculate the performance index. The accuracy metrics from the given prompt can be seen at the top of the slide. In our first attempt to improve the prompt, we changed the wording slightly and ran code again. Unfortunately, this yielded no change at all, which is depicted in the middle of the slide. Our next idea was to use our knowledge of prompt engineering and utilize ChatGPT to gain more examples. We added 2 examples to the prompt and ran the code again. As you can see at the bottom of the slide, the accuracy improved slightly, however, the precision decreased and recall remained 100%. Part of assignment 3 was to discuss how we could have further improved the performance index of our data processing and analysis workflow. We came up with the following strategies. For efficient data loading, we could use the code chunk size to read this file in smaller chunks and process each chunk separately. For the optimized data cleaning, instead of dropping all missing values, handle them based on the context. Lastly, we could have optimized SQL queries to minimize the amount of data processed. API costs can be reduced by limiting the amount of tokens processed in OpenAI. This is demonstrated by converting the call ID detail from the input file into a simple numerical ID. By simplifying the call identifier, one is able to reduce the amount of tokens processed, thereby reducing the API cost. Another way to do this is to write a code that removes any unnecessary conversation, such as greetings, salutations, sign-offs, or any other small talk.
The following is how we enhance text processing by dictionary classification. There are 2 methods. Method 1 focuses on inclusion and exclusion phrases, applying stemming and synonym expansion. It relies more on AI to generate coding that improves outcomes. Method 2, on the other hand, involves an expert check action by implementing human sense to refine and enhance performance. Both ways aim to improve accuracy and reliability, but we approach the problem from different angles. Starting with method 1, where our goal is to refine the inclusion and exclusion phrases. Firstly, we expand the inclusion phrases to enhance the identification of inquiring phrases. These involve identifying common phrases used to ask questions, such as what, why, and could you elaborate. By incorporating these phrases, we ensure that a broader range of relevant inquiring phrases was recognized. Next step, we focus on expanding exclusion phrases to improve recall by filtering out non-active listening questions. We identify phrases that are often considered irrelevant or script, such as "How are you?" "What is your name?" and those related to scheduling like email, calendar, and meetings. By categorizing these phrases in the exclusion dictionary, we largely reduce the noise in our data. And then we implement stemming and synonym expansion to reinforce the functionality. Stemming involves reducing words to their root forms in both dictionaries, ensuring that variations of the same words are treated as identical and increasing the consistency of our processing. We also expand the range of phrases by creating a dictionary of synonyms. For example, inquire was expanded to include synonyms like ask, query, and question. To automate this process, we plug a function called stem and expand phrases to ensure that all variations are covered to improve accuracy. Now here's a result table of method 1. Among all the attempts, this represents the most improved outcome. Method 1 showcases our systematic approach to refine text processing techniques can lead to significant improvement in classification performance. We will dive into this further by comparing this result with those of method 2 later.
Now I'll discuss the enhancements we've implemented using method 2, specifically focusing on our expert check enhancement strategy. Our first step involved filtering the dataset. We selected entries where columns were marked as 1 for positive examples of active listening and 0 where it wasn't evident. This filtering was crucial, as it helped us to precisely differentiate between phrases that genuinely contribute to or detract from the quality of inquiry. So with the refined data set, we updated our exclusion dictionary, which was key to improving precision. We targeted phrases like, what was that? And can you repeat that? Commonly found in non-active listening, and categorized them under intro, qualifying, and next steps. This ensures we cover all bases and avoid false positives. In refining our approach with method 2, significant enhancements were made to the rationale and overlap dictionaries to enhance our classification's accuracy and precision. We meticulously analyzed the inquiring_rational column to identify and incorporate phrases that accurately represent the intent behind inquiries. This focus update ensures that our system effectively captures the true essence of inquiring behaviors without omitting pertinent interactions. Additionally, we address the issue of overlapping phrases that often obscure analytical precision. Our overlap_x_ phrases dictionary was updated to include common conversational fillers, such as okay, right, and sorry. These are phrases that, while frequent in everyday speech, do not contribute meaningfully to the detection of active listening or inquiry. By filtering these out, we effectively reduce noise and prevent these ubiquitous terms from affecting our data's accuracy. These updates to our dictionaries not only refine what counts as significant within our dataset, but also safeguard against the dilution of valuable data by routine speech. And reviewing the enhancement's impact, we observed marked improvements. Our precision rose from 50.21% to 53.76%. Despite a slight dip in recall, the balance between precision and recall has improved, leading to better F1 scores and accuracy. These metrics underscore the update's effectiveness. Lastly, in comparing method 1 with method 2, it's evident that method 2 excels in precision, F1 score, and accuracy, particularly when combining all dictionary elements and LLM components. Given its superior performance, we recommend method 2 as the best choice for refining our text processing capabilities.
Next, we're reviewing our work in term project 5 and 6, where we analyze and improve the prompt performance by implementing both LLM and dictionary methods. We started by analyzing the prompt performance, then identifying improvement areas, and refine the prompt based on our analysis. After running the prompt, we reanalyze the performance. We then compare the initial and revised regression result. Lastly, we interpret the result and make recommendation. So in the first step, we use the review file to diagnose each prompt's performance and make further improvements. And this is the given prompt. After running the given prompt, we review the output file and identify role missing multiple applicable text, common misclarifications, and instances where clarification could be more specific. For refinement, we further split categories based on observed patterns, such as breaking down meeting schedule into previous meeting follow-up and next meeting schedule, and include the additional subcategories like discovery, rhetorical, clarification, reflection, probing, and landing questions. So on the right-hand side, we show the code that we refined. Next, we're gonna implement this refined prompt into step 3 Colab notebook, run a regression model with control variables, and interpret the result based on coefficient, p-value, and VIF. And here's a comparison confusion metric between the original given prompt and the improved prompt. We can see the modified prompt had higher recall but lower precision, making this model more sensitive to detecting positive cases. And here's a comparison table of the result from the first given and improved attempts. Here's an interpretation of the coefficient, p-value, and VIF, and these both provide a clear comparison of the result from both attempts, highlighting the significant improvement in area that may still need attentions. And these are our observations. In conclusion, the improved attempt model shows more refinement in coefficient value and slight p-value adjustment, but the overall statistical significance measure remained constant with the first attempt.
Now we'll discuss 7 key recommendations to enhance the prompts used for analyzing, inquiring, listening tactics in customer service interactions. This is based on our recent data review and analysis. Let's dive in. Our first recommendation is to incorporate detailed reasoning into the prompts. By examining the inquiring reasoning column, we can provide the AI with examples of typical reasoning patterns. This helps the model understand the context and identify inquiring statements more accurately. Next, we should highlight specific words and phrases commonly used in inquiring interactions. For instance, phrases like, "Can you explain?" or "Could you clarify?" are strong indicators. Including these in the prompt guides the AI to look for these key phrases. It's crucial to consider the overall context of the conversation. This means instructing the AI to analyze previous and next turns to determine if a statement is part of an inquiring sequence. Contextual understanding is key for accurate tagging. Leveraging linguistic style matching, or LSM scores, and interaction dynamics can significantly improve results. By paying attention to how linguistic styles match and the flow of interaction, the AI can better identify inquiries within the conversation. Handling ambiguities and edge cases is another important aspect. We need to guide the AI on what to do when statements are unclear. For example, instruct it to focus on whether the statement introduces new information or seeks clarification, avoiding mere acknowledgments. Providing negative examples is equally important. By including what does not count as inquiring, such as attempts that simply acknowledge or agree, we help the AI distinguish more accurately. This clarity reduces misclassifications. Lastly, expanding the vocabulary and including various forms of inquiring statements can enhance the AI's performance. Phrases like, "Could you tell me more?" or "I'm curious about" should be part of the prompt to capture a wider range of inquiries. By implementing these recommendations, we can significantly improve the accuracy of our AI in identifying inquiring tactics. This comprehensive approach ensures a better understanding and analysis of customer service interactions. Thank you for your attention, and we're open to any questions you might have.